So hello, my name is Matěj Gregor, and as said, I am from Czech Republic, Brno University of Technology. And in this presentation, I would like to share some experience about rogue router detection. As we heard yesterday, this problem was mentioned in almost every presentation, so I will be another one. As we know, the problem is connected with 6to4 tunneling techniques. Here is the 6to4 header. We can see that we need public IPv4 address, which is after the 6to4 prefix. What is maybe more interesting, if you want to make some statistic about which operating system use these techniques, or how many, you can use these well-known and user identifiers. If Windows act as a gateway, the IPv4 address is in last 32 bits. If it acts as client, it generates EUI as usually with privacy extension, so temporary address. If Linux or macOS use 6to4, the gateway is ::1, and clients usually use EUI64. In our network, the Windows are responsible for almost whole traffic because macOS is not so spread in students' dormitories. As we know, the problem is with internet connection sharing in Windows Vista. Windows 7 somehow fixed it. So if the native IPv6 is deployed in the network and Windows 7 listen that there's some router advertisement, it will not use 6to4 mechanisms. But Vista ignore it, so they will use it. When I ask users why they have this internet connection sharing, they usually say that they use it at home to share Wi-Fi. So we cannot blame the user that they are using this technique. The problem is, as I said, with Windows Vista, because when they share the Wi-Fi and then connect to the LAN in our network, it doesn't matter that the Wi-Fi is not used. It still broadcasts the prefix into the network. Is it a problem? I think so, because here are some statistics about the numbers of rogue routers in our network. Usually you can see that during the evening it's around 20 computers. You can imagine that what mess in network new one DHCP version 4 when, for example, some users switch wireless router and so on. So it means that you have 20 of them in the network. So what's usually, or what's the problem? Consider first IPv4 only network and 2 computers and 1 rogue router, which broadcasts this router advertisement. There are 2 scenarios. One, that computer A will use IPv4 to connect dual stack router, dual stack server, and computer B will use IPv6. If the server has only IPv6 address, 6to4 will use all computer A also and computer B. IPv4 connection will be used if the devices or operation system implement RFC 3484. It's preferences of addresses. So 6to4 is has lower preferences. That's because it's usually broken. As we heard yesterday, there are several problems with previous version of Mac OS. For example, Android prior to 2.2 also use IPv6 with high priority. And all other softwares who use own resolver, for example, Opera as mentioned yesterday. If we have IPv6 deployed in our network, there's a little bit problem because with router advertisement, it also broadcasts default gateway. However, which gateway should be chosen? This is example of my computer connected with our network, and you can see that I have 3 default gateways. Operation system does not know which gateway should be used, so it's usually some round-robin mechanism. So sometimes it works, sometimes it's not. Usually the routes are not optimal. So in Czech Republic, CZNIS, which is domain name registrator, use 64 relay, and so optimal traffic flow should be via this relay. However, this is the usual scenario. So the flow first go to Netherlands and then go back. So if I am using this 624 rogue router as my default gateway, and I am connecting to some web page or web server in Czech Republic, the packet first go to Netherlands and then go back to Czech Republic. However, these are the best scenarios. Usually Windows have firewall enabled and they discard the traffic. In recent version of Windows Vista, it seems that it has to be somehow fixed. So when I tried last week and I tried 15 these rogue routers, it worked every time. So there was just a little delay. However, it can happen that it will drop IPv6 connection. Possible solution were also mentioned yesterday. It's router advertisement guard, but however, we cannot use this because we don't have switches that are capable of. Only Cisco and maybe some recent version of HP can do this. Send no one except Cisco. We cannot use IPv6 ACL because the access switches are not capable, doesn't have this function. So the only way how to solve it is monitoring the network and sending router advertisement with 0 lifetime. You can also configure router advertisement with higher priority. However, we also cannot do it because we are using router advertisement daemon in our switches, and it's not possible to configure this option. Here are some monitoring softwares. Usually they are written to FreeBSD platforms. So for example, if you want to use Rafix on Linux, you have to patch it or do some small programming. However, there is a nice tool, Scapy, which I will mention after a while. So this is our network, student dormitory network with around 6,500 students. We have to monitor 11 VLANs. There are several problems connected with it. These tools, Ramond and Rafix, are useful just for unregistered router. However, as we heard yesterday, there are another problems like duplicate address detection attacks and so on. So it's useful that you also use NDP-Mon, for example. However, this software cannot run on multiple interfaces. There are also several problems with Mac OS. For example, handling router advertisement with lifetime of 0. So if this happen, so the macOS will install default gateway. It will happen only when prefix information option is in the router advertisement. But, so you can say, okay, we will not include this prefix information options. However, when the macOS has only link local address or site local address, and you will send a router advertisement without prefix information, there will be delayed with AAA records. Maybe that's your problem also. So here's the simple SCAPI script you can use for sniffing an unregistered router. The SCAPI is useful if you want to connect the output of this to some databases to monitor them later. However, there are several problems with it. I found several bugs in Python and SCAPI. So because it has to be a daemon, so it's supposed that the daemon should be run for forever in the best scenarios. However, after a while, the Python takes a huge load and sniffing is not possible. So solution is restart the script every few hours. It maybe works, but it's not clean. So I try to also port the script on Linux. However, there's problem with Ethernet driver for Ethernet cards that strips the VLAN text before pass it to the filter. So you cannot use this filter. It works, but there are probably better ways how to do it. Now University, Petr Lampava wrote Enable Discovery Watch, which is a program that includes all these things together. So you can use as a router advertisement and also as NDP-mon. It's capable to run on multiple interfaces and check the ICMP v6 packets as described in RFC 4862. There are also problems with NDP-mon that this software stores configuration and databases in XML files. So if you have, for example, this 6,000 user, it will create really huge XML, and if the program fails, the XML is usually broken, so you have to start again and over. This is the last slide is the number of 64 prefixes, unique 64 prefixes, which our university communicate every day. So you can see that that's around 5,000 prefixes per day. That's all, if you have some questions.
When you see rogue IPv6 routers, do you disable the switch ports also?
No, because we just send the router advertisement with 0 lifetime, because if you disable the port, the user cannot access the internet. So, and it is working without a problem. So.
If I can add, it doesn't help because other computers also have this router, so disabling this port doesn't help at all.
So if you don't disable the user port, how do you get the user to fix their configuration? Or it just keeps on being broken?
If the user computer receive the router advertisement where the 0 lifetime is set for, because you spoof the address, you you send the same router advertisement as the 6 to 4, but you set the 0 lifetime. Okay? It's clear? You will
Yes, I think
And
I
if-
understand that you can eliminate the effect of
Yeah.
this misconfiguration by sending these arrays, but you cannot get the user to fix their computer so that it wouldn't break in other networks, or
Yeah,
the user
it
could...
will not.
Yeah, so...
But we cannot solve it. You can go to the user and say, okay, it should not be. You can switch it off, but the user will say, what?
But if you would, for example, turn off the port, then the user would need to do something.
Yeah, that's maybe true.
Yeah. So, well, there are trade-offs there. But,
I think there is a little bit problematic to switch off the user because it's the regular service that Microsoft implemented. I think this behavior is how Microsoft wanted to do it, and I think it's very problematic to disable this user because he doesn't do anything bad. Microsoft just implemented it into their operating system, and I think that's the problem. And this problem is known for more than 2 years, and Microsoft still didn't do anything about it.
Okay, thank you very much, Matej.